Hey guys, welcome back to another lesson of Algebra 2 Semester 2. Today we're going to be covering some samples, sample sizes, and margin of error. It's a lot of equations and a lot of plugging numbers into equations. So you're going to want to make sure you're highlighting these, making them stand out, something like that, so when you take the test next, you have all that prepared. Yes, we do have a test next, so as soon as you're done with this lesson, if you want to turn it in and go take the test while everything's fresh on your mind, feel free. I don't mind. This is the end of chapter 12. Then we just have a few assignments on chapter 8, and then you guys are done. Woohoo! All right, let's get into this. So our first thing is, in a sample of 350 teenagers, 294 have never made a snow sculpture. Find the sample proportion for those who have never made a sculpture as a percentage. All right. This really is as simple as it reads. You just go 294 divided by 350. All right, when you punch that into the calculator, you are going to get out a long number. I want you to round to, actually I think this one comes out nice. It comes out as 0.84. When you're doing this, always round your decimal points out 4 places, and you'll see why in just a second. So this is not a percentage, this is a decimal. So then to get, this is a percent, you have to multiply this by 100, which in this case will move the decimal point 2 places to the right and give us 84%. All right, that means that 84% of teenagers have never made a snow sculpture. I'm betting they did not poll any Minnesota teenagers. All right, pause the video if you need so that you can think about this for a minute. And we're going to do the next one together as well. So we have, in a poll of 1,085 voters, 564 favor candidate A. Find the sample proportion for those who favor candidate A. Again, all we're going to do is 564 divided by 1,085. All right. And when you plug that in, you're going to get a long run on decimals. So here's where I said go to 4 decimal places. So 0.5198. Now I have this written down on my piece of paper because I thought I would be doing this in person with you. So if you don't know where I got the 8 from, when you are rounding, if your next number, so the number, the 5th number after the decimal, if it is 5 or above, you round up. If it is below 5, then you round down. So, again, I wish I was doing this in person so I could have you guys look at the calculator and then go from there, but circumstances aren't allowing for that. So if you're not getting where I get the 8 from, that's where it's from. If the 5th decimal point was 5 or above, I rounded up to 8. These are rounding tricks that we should be remembering, you guys. So then the next thing we do is we multiply by 100 to get our percent, which gives us 51.98% of voters favor candidate A. So for those of you who have to always ask me, when am I ever going to use math in real life? Here's a perfect example. We are voters. This is what we do with our lives. All right, so the next thing we have to do is we have to talk about margin of error. So let me get my highlighter out. Maybe not. I don't remember which one the highlighter is. Okay, well, I guess we're not going to highlight. That's fine. So the margin of error is based on the standard deviation in graphs. The larger the sample size, the smaller the margin of error. This is why we'd like to take big samples when we are doing polls, when we're doing tests on stuff like that. That's why you don't really often see, oh, scientists conducted a survey on 5 people. Here's what they got, because that's not a good enough sample size. So the equation for margin of error is 1 over the square root of n. I want you to take your pencil and box that, or highlight it, or something. Make it stand out because that will come up on your test. And then write a little note where n is equal to the sample size. Margin of error is a percent, and you're going to see that when we do it on our next problem. Pause the video if you need to catch up. So we have, the next problem says, a survey of 2,580 students found that 9% are left-handed. Find the margin of error for the sample. Right? There's a lot of extra information in this one that we don't really need. The number we are going to focus on is 2,580. So we go back to our handy-dandy equation, 1 over the square root of n. And we get is equal to 1 over the square root of 2,580, which comes out to be approximately 0.0197. But this is not a percent, so the last thing we do is we multiply by 100, which gives us 1.97%. Now I know a lot of you would like to think you're done with this problem, but we aren't quite yet. The margin of error for the sample now is a positive or negative 1.97%, right? So if you look at the, oh, it doesn't do it on the paper. I'm sorry, guys, that should say positive or negative 1 over square root of n. It's really important because then on the next couple of problems, we are going to find the interval likely to contain the true population portion, and it's important that we have positive or negative here, all right? So if you need to add that onto your equation, please do so now. It should say positive or negative. Okay, take a moment to do that, and we are going to get started on this question. In a poll of 123 students, 87 have never ridden a ferry. Find the following, the sample proportion. Okay, part A is, our sample proportion is like what we did on the first two problems. So we just take 87 divided by 123, gives us 0.7073, which is equal to 70.73%. I'm going to skip the whole multiply by 100 because I assume you guys know that that's what I'm doing by now. For part B, we have to find the margin of error, which is a positive or negative 1 over our sample size, which is 123, so square root 123, which gives us approximately a positive or negative 0.0902, which then becomes positive or negative 9.02%. Finally, part C is the new step. Find the interval likely to contain the true population proportion. All right? That sounds like a complicated process, but all you are doing is adding and subtracting 9.02 to 70.73. So I'm going to extend the page here, hopefully. And I'm going to go 70.73 minus 9.02. And I should be labeling these with percents, but I'm not because I apparently am not a good enough math teacher to actually be labeling my symbols. And then we have 70.73 plus 9.02. So notice how one is minus, the other is plus. All right, when you do that, you're going to get out 79, wrong, I had them backwards, I apologize. You're going to get out 61.73 and 79.75. Okay, you're going to take these two numbers here, and that is your interval. So you're going to write your answer as 61.73% to 79.95%. And that is your interval likely to contain the true population. There's only only one question left. You guys have to finish that one on your own. I know you guys would love if I did this entire assignment for you, but I want to see what you've learned. So go through and try to do that by yourself. Good luck, and hope to see you guys soon, hopefully in person.